World's smallest QR code. Invisible, record-breaking, and built to last, the world's smallest functional QR code is now officially a Guinness World Record holder, though you'd need an electron microscope to see it. The barcode, measuring just 1.977 square micrometers, is smaller than many bacteria and air pollution particles. The science behind the shrink, a team of 7 scientists from Austria's Vienna University of Technology, TU Wien, and the data storage company Cerabyte created the code. The breakthrough isn't just about making something tiny, it's about making something readable at that scale. As materials scientist Paul Merhofer explains, structures on the micrometer scale are nothing unusual today. But that alone does not result in a stable, readable code. To achieve this, they printed the QR code onto a ceramic film using focused ion beams to etch pixels just 49 nanometers, across 10 times smaller than the wavelength of visible light. This makes the code completely invisible to the naked eye. The verification process was conducted under strict witness conditions and independently confirmed by the University of Vienna. Why does this matter? Durability and density, this isn't just a novelty. The underlying technology addresses a real problem: data storage. Current digital storage methods are energy-intensive and degrade over time. Ceramic storage, as TU Wien scientist Alexander Kernbar notes, offers a solution inspired by ancient civilizations. We write information into stable, inert materials that can withstand the passage of time and remain fully accessible to future generations. The team estimates that their method could store over 2 terabytes of data on a single A4 sheet of paper. This density, coupled with the ceramic's durability, suggests a potential path toward long-term, low-carbon data archiving. This isn't just about breaking records. It's about rethinking how we store and preserve information for the future. The research offers a glimpse into a future where data storage is both incredibly dense and remarkably resilient. The team's next goal is to scale up this technology, offering a sustainable alternative to current storage solutions.